Welcome to the deep dive. So, you, like most people, probably get the basic idea of 3D printing. That process of building an object layer by painstaking layer.
Hmm.
But knowing what it is, additive manufacturing, and really understanding the profound change it's driving across industries globally, those are two very different things.
That's absolutely the key point. For years, 3D printing felt, I don't know, a bit like a niche hobby, or maybe just a cool gimmick.
Right.
But today, its real power isn't just that it's novel, it's in what it enables. Things like personalization, amazing geometric freedom, and just this incredible speed up of the whole digital to physical timeline.
Okay, so our mission today is really to cut through the hype, the buzzwords. We've dug into the sources to pull out the really important examples showing how this tech is fundamentally changing how we design stuff, how we make things, even how we heal, and how we build the world around us.
Sounds good.
Let's start where it really began making waves, the factory floor. So the first, and maybe still the most widespread use, is rapid prototyping. Sounds a bit generic, maybe.
Yeah, I can sound that way.
But when huge companies, think General Motors or PepsiCo, use it, they're not just making a little model. They're actually, compressing the whole competitive landscape.
Exactly. And what's really fascinating there is the sheer speed increase. I mean, in a traditional design cycle, making a mold or the tooling for a prototype, that could easily take 6 months.
6 months, wow.
Yeah. Now, these companies can print and, importantly, test multiple functional versions of a part or maybe some packaging in just, say, 3 to 4 winds.
Okay, that is massive.
Yeah.
That means they can react to what the market wants or what customers are saying almost instantly.
Pretty much.
But let's look at the real workhorse application. The kind of use that doesn't really grab headlines. Jigs and fixtures.
Ah, yes. Good.
Most people don't really think about these, right? These custom tools for assembly lines. But they're essential. And traditionally, making them meant specialized, expensive machine shops, lots of expertise needed.
And now, often they're printed right there on site. If you think about the bigger picture, it's almost a form of democratization of manufacturing.
How so?
Well, instead of relying on these big, centralized, expensive tooling departments, even smaller manufacturers can now print their own custom assembly holders, guide templates, brackets, that kind of thing.
Okay.
And they're cheaper, they're faster to make, and crucially, they're often lighter and more ergonomic for the actual workers using them all day. It really changes the whole labor dynamic sometimes.
That makes sense. It sounds like the real power isn't just making quick models, but it's getting into the material science needed for actual end-use parts.
Yeah.
Especially where weight is a really big deal. I'm thinking aerospace, maybe high-end cars.
That is the critical step up, absolutely. To save weight, you need materials with really advanced properties. So now we're seeing components printed using things like carbon fiber-filled nylon. Engineers usually call it PACF. It's a super strong composite. Or even PEEK. That's a specialized plastic known for handling extreme temperatures and chemicals. You find it in medical devices, jet engines, that sort of high-performance application.
So why does printing the part actually make it lighter than, say, machining it from a block? Is it just the material itself?
Well, the material helps, but the big advantage is the geometric freedom. See, traditional manufacturing often starts with a solid block and you cut material away. Wasteful.
Right.
Additive lets engineers design parts with really sophisticated internal structures. Think like a honeycomb pattern inside the part.
Okay. Like bones almost.
Kind of, yeah. It gives you the strength and stiffness you need, but you can remove maybe 70, even 80% of the material mass. And that leads directly to things like less fuel used in planes.
Like connecting this back to the big economic shifts you mentioned.
Yeah.
On-demand spare parts. What does that look like logistically? How does that work?
It fundamentally changes inventory. Instead of these huge, expensive warehouses scattered everywhere, full of thousands of specialized metal parts just sitting there.
Waiting to be needed.
Exactly. Waiting, tying up millions in capital. Now, you shift to essentially centralized digital libraries, files. A company only prints the specific part it needs right when it's needed. That changes global logistics, inventory management. It's a massive shift.
Wow. Okay, that transition from mass production to these specialized on-demand parts. It feels like nowhere is that more critical, more personal than in healthcare.
Oh, absolutely. This is where 3D printing really moves away from that one-size-fits-all approach to, truly bespoke solutions, perfectly tailored to an individual patient.
So how does that work in practice?
Well, take a situation where a patient has a really complex, maybe life-threatening condition, say a child's heart with a rare defect or a tricky brain aneurysm. Surgeons can take that patient's specific CT or MRI scan data
Okay.
and print an exact physical replica of that specific organ or that specific blood vessel.
So how game-changing is that pre-surgery practice? I mean, does it
Yeah.
really lead to better outcomes for the patient, or is it more of a, nice visual aid for the doctors?
Right. Oh, it absolutely translates into measurable results.
Hmm.
There are studies showing that when a surgeon gets to practice a complex procedure on a perfect replica beforehand,
Right, yeah.
the actual operative time decreases significantly, sometimes by hours.
Hours, really?
Yes, and that means less time under anesthesia, which reduces the risk of complications and generally leads to a quicker recovery for the patient. It just minimizes the surprises once they're actually in the operating room.
That's incredible. And beyond just planning, we're now seeing actual implants being printed. Right, fully customized ones.
Correct. We're seeing things like titanium cranial implants, custom made to perfectly fit someone's skull after an accident for reconstruction, personalized spinal implants too,
Wow.
and even joint replacements made from materials like PEEK that integrate just perfectly with the patient's own unique anatomy. It can really speed up healing. And of course, you can't ignore the sort of quiet revolution it's caused in dentistry.
Ah, right, like the clear aligners.
Exactly. Those custom clear aligners that have pretty much replaced old school metal braces for many people. Plus printed surgical guides for placing implants precisely, models for making crowns and bridges. It's transformed the field.
Okay, but the future frontier, that's what really needs the deep dive. What are researchers working on now that sounds like, well, pure science fiction?
Right, there are two areas really pushing the boundaries ethically and technically. First, bioprinting. This is the huge ongoing effort to print actual living tissues, maybe eventually even entire organs.
Using the patient's own cells.
Using the patient's own stem cells, ideally. The goal is, well, it's simple to state, but incredibly ambitious. Eliminate the problem of transplant rejection completely. Build the organ from the patient's own biological material.
That's mind-blowing. Okay, in the second area, you said it might be more immediately achievable.
Yes, and this one is fascinating too. Personalized medicine delivery.
Meaning?
Think about individualized pharmaceuticals. Imagine your local pharmacy printing a single specialized tablet just for you.
A single pill.
A single pill containing the exact custom microdose of several different active ingredients that you specifically need, all combined perfectly. It could simplify really complex medication schedules and hopefully maximize effectiveness while minimizing side effects.
Okay, so if we can customize a skull implant down to the micron level,
Yeah.
what happens when we apply that kind of personalization, that complexity, to the scale of, say, a house, moving from the micro to the macro, architecture and construction?
Yeah, it's a great question. And here, the technology lets architects realize visions that were just, well, impossible before. It certainly replaces the old, laborious cardboard models with quick, detailed architectural prints that's useful.
Sure.
But the real impact, again, is on the geometry of the design. Printing frees designers from the constraints of, straight lines and simple angles imposed by traditional building methods.
So we're talking about those really organic, complex shapes, maybe inspired by nature. Things like Antoni Gaudi's work in Barcelona.
Exactly like that. Those kinds of forms were previously either incredibly technically challenging or just financially out of reach for most projects, too expensive to build.
Yeah.
But now, using 3D printing, you can create complex, curved structural elements that are actually viable, relatively inexpensive, and highly customized. Firms like Zaha Hadid Architects, they've used this a lot, creating fluid, non-standard concrete molds and panels for their buildings.
Yeah.
Stuff that would have been prohibitively costly otherwise.
Okay, and speaking of massive scale,
So,
we had to touch on printing entire homes. It sounds amazing on the surface.
yeah.
Faster, cheaper, less waste. But what's the catch right now? Is it just printing the concrete shell, or does it include, like, the plumbing and wiring and insulation?
Right, that raises a necessary bit of skepticism. And yes, right now it is primarily the concrete shell. You have these giant robotic arms applying layers of special mortar or concrete very quickly, very efficiently. And it does reduce material waste significantly, maybe up to 60%. But you're right, the finishing work, the roof, the plumbing, the electrics, the windows, that still needs traditional construction trades.
All right.
The advantage, though, is definitely speed and that material efficiency. So it makes it a really promising idea for things like disaster relief housing or maybe quickly building affordable housing projects. Still experimental, but promising.
Okay, so we've gone from aerospace parts to custom organs to potentially houses. But how does this technology filter down to, well, to you listening? What about accessibility, education?
This is where we can talk about literacy, in a way. For students, especially in STEM fields, science, tech, engineering, math, 3D printing is just invaluable.
How so?
They move from abstract concepts on a page, geometry, physics, to a physical thing they can actually hold, test, modify. They grasp engineering principles almost instantly. It transforms education from just passive listening to active creation.
And for the everyday listener, the DIY type, the person trying to fix something at home.
Yeah, for them, it's like a literal toolbox upgrade. You can design and print custom organizers for that weirdly shaped drawer in your kitchen.
I need that.
Right, or create unique figures for board games, personalized gifts, or, and this is critical, print replacement parts for household appliances where the original part isn't made anymore. You become the solution to planned obsolescence in a small way.
That's powerful.
And the art world benefits too, of course, creating complex jewelry, sculptures, even avant-garde fashion pieces where intricate structures are printed directly onto fabric. It opens up creative possibilities.
So we've kind of traced this journey from, 1980s experiments to this really diverse, vibrant ecosystem we see today. The basic principle, building layer by layer, seems simple, but it unlocks this amazing freedom of shape, material efficiency, and that super fast digital to physical transformation. Where does it go next, though? What's driving the future?
That's the key question. Looking ahead, the next phase probably won't be about inventing entirely new types of printing, but more about refinement. And that refinement seems to be driven by three key trends.
Okay, what's the first?
The first is simply speed, nonstop pursuit of faster production. The market just demands parts faster, whether it's prototypes or end-use components. Companies like Bamboo Lab have really shaken up the prosumer and small business market recently by focusing intensely on speed and reliability.
Right, I've heard of them.
And you can expect that push for speed to just keep scaling up into the bigger industrial machines as well. Faster, faster, faster.
Always faster. Okay, makes sense. What's the second major push?
Material science. We constantly need new filaments, new resins. The demand is huge. We need materials with better mechanical performance for high-stress industrial parts, better thermal properties for things like under-the-hood car components, increased chemical resistance for various applications.
And sustainability must be part of that, too.
Oh, absolutely. A massive focus now is on sustainability, developing biodegradable filaments or filaments made from recycled materials that crucially don't compromise on performance. That's a huge area of R&D.
Okay, speed, materials. And the third trend. This feels like the automation layer software. That's what makes a system truly scalable, right?
Precisely. The third leg is software and artificial intelligence. This is going to define the workflow going forward. We're talking about slicers. That's the software that translates the 3D model into the printable layers for the machine becoming much, much smarter.
How so?
AI will start to automate really complex tasks, things like figuring out the best way to orient the part on the print bed or automatically generating the optimal support structures needed during printing. We're moving towards these automated print farms where AI detects potential failures instantly.
Yeah.
It just makes the whole process dramatically simpler, more reliable, less dependent on expert users for every single step. Hashtag outro.
Okay, wrapping this up. What really stands out to me is just the incredible breadth of it all. You know, from the deep personalization of complex medical devices and really intricate architecture, all the way down to making simple industrial jigs cheaper and faster, or even just solving those little annoying problems we run into every day at home. It feels like a technology driven by this dual demand for like hyper efficiency and hyper customization.
It is truly astonishing when you step back and look at it. But maybe the concluding thought, the thing to really leave you with is this. 3D printing isn't just another manufacturing tool you might use someday.
Okay.
It's becoming, arguably, a new form of literacy for the 21st century. It gives you the ability not just to passively consume products designed by others, but to actively participate in creating, modifying, repairing the physical world right around you.
A new literacy, I like that.
The future isn't just going to be printed for us, it's going to be created. And now hopefully you feel a bit more equipped to be part of that creation.